Good morning. Today I'll be talking about some work from my PhD, which I completed at the Stellenbosch University in the Department of Conservation Ecology and Entomology. I used insect calls, specifically bush cricket calls, to determine the conservation value of both anthropogenic and natural ecotones within the landscape. So what exactly is an ecotone? Firstly, it is a transition zone between two adjacent biotopes. If you look down here at the bottom, you will see that we've got an ecotone existing between the indigenous forests and the natural grasslands. Now, this ecotone is often maintained by natural processes such as fire, which burn through the grasslands, but prevent trees from expanding outwards. Now, at this ecotone, or at any ecotone, there's often mixing of the abiotic and biotic conditions of both adjacent biotopes, which often result in species showing specific responses dependent on the level of specialization within each species. Here at the back, you'll notice that we've got an anthropogenic ecotone, which exists between the indigenous forests and the eucalyptus plantations. Now, this ecotone also has mixing of conditions, with species being able to respond differently to the ecotone, but it is also maintained, importantly, by anthropogenic activities, in this case, rotational timber production. What you have just heard there is a snippet of this landscape, soundscape. Now, soundscapes are formed by animals communicating either with one another to attract potential mates or to defend their territories against rivals. So, soundscapes often vary in accordance with the landscape and vegetation or landscape characteristics. Now, not only across the spatial scales, but soundscapes also vary temporally, seasonally, and throughout the day. So, for example, this landscape at night sounds a little different. As you can hear, the same landscape has a completely different soundscape at night. Instead of hearing birds, you now have a soundscape which is largely dominated by insect calls of Orthoptera, so your crickets and your bush crickets calling at night. So that brings us on to bush crickets. Firstly, what is a bush cricket? Well, bush crickets are members of the Orthopteran order, and their family name is Tetigonidae. They are close relatives of both crickets and grasshoppers, and fascinatingly enough, they are nocturnal. And to add to the allure to work on these creatures, the males produce species-specific songs. So, as most of you know, you can identify a bird based on its call, and you don't have to hear the bird. So exactly like this, you can go out into a field at night, you can hear your bush cricket call, and you can identify the individual without actually having to see the individual, because they are highly cryptic and hard to identify in the field. So this leads us on to acoustic monitoring. Now, because they communicate acoustically and with such a variety of songs, it's easy to go out and record them, and you want to because you can get a great number of species out of one recording. Now, bush crickets also vary with accordance to vegetation cover, so because they rely on vegetation for ovipositioning sites to lay their eggs, to call from, and as well as to camouflage. As I mentioned, they're highly cryptic. And it's also known that landscape transformation and habitat alteration changes the assemblage of bush crickets in the environment. So that brings us on to ecotones. How does a changing ecotone in a landscape between either a natural or an anthropogenic ecotone, how does that impact, firstly, the distribution of bush crickets, and secondly, the soundscapes within these areas of transitions in the landscape? So that brings me to the aims of this project of mine. Firstly, it was to determine the species richness and assemblage composition responses of bush crickets to ecotones within the landscape, and to compare these to those found within the core biotope sampled. Secondly, it was then to determine the environmental drivers of bush cricket distribution in the landscape, and finally, to determine whether or not specific species show an affinity to one or a range of particular biotopes, and how the ecotones between the biotopes may impact the distribution of the species in the landscape. But for the purpose of this talk, I'll be focusing in on the first aim, looking at the distribution and response of species at ecotones. So I focused my work within the Bainsfield, Burn Valley and Richmond areas of KZN in South Africa. I selected 60 sites in 7 different biotopes. Now, these biotopes consisted of 4 core biotopes being closed canopy eucalyptus plantations, open canopy eucalyptus plantations, indigenous forest remnants and grassland tracts. And then I selected 3 ecotone sites regions between these, being the forest grassland ecotone, the plantation forest ecotone, and the plantation grassland ecotone. I used both SM4 song meters and SM2 song meters to record the soundscapes, and I recorded for 5 minutes every 2 hours for 4 nights between 7 o'clock at night and 5 o'clock in the morning. A quick overview of the methods that I used for this. I used Raven Pro, a computer software program, to visually represent each individual recording as a spectrogram, where we have time on the x-axis and frequency on the y-axis. From this, you can see that there are at least 4 recognizable patterns within the spectrogram. The orange and the green squares indicate bush cricket calls, the purple down here are crickets and were not included in further analyses. From this, we can then count the number of species calling to get a species richness per recording, and we can also take the begin and the end time of each call and the differences between them to calculate the total time in seconds that a species was calling at an individual site. And then thirdly, taking the number of recordings that a species was present in, at a site, it's possible to determine an acoustic activity index, which serves as a proxy of abundance because it's not possible to determine total abundances from single channel recordings like these. So in total, I recorded almost 90,000 individual bush cricket calls, which were identified to species level or acoustic species if the identification was not known. And from these, 11 species were identified, which is surprisingly low considering that the study site is in a biodiversity hotspot. And also, temperature was found not to influence the species richness of the recordings because it is known that temperature impacts the singing behavior of orthopteran species. So to jump right into the results, using mixed models, I assessed the distribution of species richness across the 7 sample biotopes, starting from least woody, which is your grasslands, grassland plantation ecotones, forest grassland ecotones, open canopy plantations, closed canopy plantations, the ecotone between closed canopy plantations and the indigenous forests, and the indigenous forests themselves. As you can see here, there's no real significant differences between the species richness observed at the different biotopes, but the forest grassland ecotone, interestingly, is. Now if we compare the acoustic activity of the different biotopes, you will notice that there is definitely a significant increase in acoustic activity of bush crickets at the forest grassland ecotone, which is rather interesting. And finally, comparing the total call times of all the species at all the recordings at all the sites in the different biotopes, the forest grassland ecotone as well as the grassland plantation ecotone and anthropogenic ecotone were significantly higher in call times compared to those of most of the other biotopes. Again, biotope type significantly influences bush crickets. In this instance, it's the composition which is significantly influenced. As you see, biotope woodiness is increasing left to right, with open biotopes being here on the left-hand side, the more woodier ones here on the right-hand side. So as the biotopes shift in woodiness, so does composition change of the bush cricket assemblages. The grassland bush cricket assemblages is very similar to those of both the grassland plantation and grassland forest ecotone assemblages, whereas our closed canopy plantations, those with the blue squares, are very similar to those of the forest plantation ecotones. And the composition of our closed canopy and open canopy plantations are not significantly different from each other. And so this shows us that our core biotopes here on the edges are significantly different to each other with species assembly. So what does this mean for ecotones and bush cricket diversity within this landscape? Well, firstly, we have marked changes in both species richness and assemblage composition at ecotones. Firstly, species richness is significantly higher at the forest grassland ecotone, which is interesting as this is a natural edge within the landscape. And then secondly, as you will see, as you've seen, the assemblage composition changes across this ecotone. The assemblage of the grasslands and the grassland forest edges are significantly different to the assemblages sampled within the indigenous forests themselves. Similarly to the forest grassland ecotone, the plantation grassland ecotone also shows a marked change in both species richness and species turnover. There is an increase of species richness of bush crickets at the ecotone between the plantations and the grasslands, as well as the grassland species composition being significantly different to that of both the plantation and the plantation grassland ecotone. This suggests that the bush cricket community within this landscape are responding to changes in vegetation structure between biotopes, and this results in the high species turnover that we are observing. So what does this mean for bush cricket diversity within the landscape? Well, the increase in species richness at the forest grassland ecotone as well as the plantation grassland ecotone suggests that there is a wider variety of resources available and can support more species in either the plantation or forest and grassland can. Secondly, the higher acoustic activity numbers and calling times at the forest grassland ecotone suggests that there is improved and facilitated communication for the species at these ecotones. And then if we look at the forest and the plantation boundaries, the assemblages don't differ between these woody environments, which suggests that the vegetation characteristics are driving the bush cricket assemblages in this landscape, as well as these transformed regions of the environment being conducive to allow bush crickets to move across transformed regions of the landscape between patches of indigenous forest. So what does this all mean for conservation in the landscape? Well, natural ecotones are essential to maintain the full complement of bush cricket species. Secondly, anthropogenic edges are not without value in these complex landscapes, but they are not a replacement for natural edges. Thirdly, this landscape maintains high heterogeneity, which in turn supports higher number of species. And finally, natural edges are thought to buffer the core biotopes, but these have been proven to be important in their own right. Finally, I would like to thank my supervisors, as well as Mondi for funding, and NCT, Mondi, and all the private landowners who allowed me access to the sites, and my many field assistants who helped me with this work.